A pump is a device used to move liquids or slurries. A pump moves liquids from lower pressure to higher pressure and overcomes the difference in pressure by adding energy to the system. In general, pumps can be classified as either positive displacement or dynamic.
This is a positive displacement gear pump. We have low pressure oil coming in here to this side of the gear. The oil is trapped around these gear pockets as the gear is rotated around. Oil is then pressurized on this side as the two gears mesh, and high pressure oil comes out this side. This is a G-rotor style oil pump. The low pressure oil comes in on this side. As the gear is turned, it gets caught in these gears and pressurized on this side and comes out on an outlet on the outside. There's a small flange that sits on here with the inlet to the oil here, small hole, and a small hole for the outlet here, which is pressurized oil.
Go through its two strokes, you can see exactly what's happening. Let's start with the spark plug firing. At this point, the piston is at the top of its stroke. The cylinder is full of air and gasoline that has been compressed. When the spark plug fires, it lights the gasoline. The gasoline bursts into flame and expands rapidly, driving the piston down with a lot of force. See this area behind the piston? It's filled with air and a mixture of gasoline and oil. As the piston moves back into this area, it compresses the mixture. As the piston gets near the bottom of its stroke, it uncovers a port. That port lets the exhaust gases escape into the exhaust pipe. Then, just a fraction of a second later, the piston uncovers another port. That port lets a new charge of air and gasoline into the cylinder. Now the piston starts moving back toward the spark plug, compressing the air and gasoline mixture so the spark plug can fire again. This cycle repeats thousands of times per minute. You can see that the piston is doing three things besides being a piston. It's an intake valve, an exhaust valve, and a compressor. Because the piston is doing so many different things, it makes the engine incredibly light. You can also see that the spark plug fires once for every rotation of the crankshaft. That's twice as often as the spark plug fires in a four-stroke engine.
Of hydraulic pumping by combining a patented downhole jet pump with a highly efficient surface-mounted hydrocell diaphragm pump. With no moving parts, the JJ Tech downhole jet pump operates longer with reduced wear, servicing, and downtime. It needs no rig for servicing, is easy to optimize, and is retrieved to the surface by pumping in reverse. The JJ Tech Jet pump's performance stems from its ability to use one fluid to move another fluid. The pump nozzle creates a Venturi effect at the intake. The resulting vacuum pulls produced fluid into the pump. The intake directs the produced fluid into the jet. In a mixing tube or throat, the power fluid encounters the produced fluid, where it combines and accelerates to an average velocity. In the pump's diffuser, the velocity of the mixed stream is converted back to pressure, and the combined fluids lift to the surface. The production rate is determined by adjusting the nozzle pressure through the throat and nozzle in combination with the reservoir energy at the pump. A wide range of production rate and lift capacity is possible. The JJ Tech jet pump is built with proven materials and proprietary coatings to improve reliability and resist erosion and corrosion. Direct flow paths and larger flow areas improve efficiency over other designs. Ultra-flow production systems can be used in a variety of applications, including vertical downhole completions, horizontal and deviated wells, dewatering gas wells to maximize daily production and increase total recoverable reserves. During frac flowbacks and well cleanup, much higher return rates can be achieved. The heart of the ultra-flow production system is a hydrocell diaphragm surface pump manufactured by Monir Engineering. This cutting-edge, hydraulically balanced diaphragm pump drives power fluid to the downhole jet pump, lifting produced fluid to the surface. Unlike a conventional plunger-type pump, the hydrocell diaphragm pump has a sealless design without packing or cups that can fail and interrupt production or compromise the environment. By eliminating contact between the pump's internal components and abrasive materials in the pumped fluid, the Monir diaphragm pump greatly reduces overall wear and maintenance. The pump is driven by an electric motor or gas engine via either direct drive or pulleys. The pump's crankshaft drives plungers that hydraulically expand and contract a single diaphragm in each of the pump chambers. Sequential expansion and contraction hydraulically open and close inlet and outlet valves, circulating fluid out of the pump at pressure up to 4,500 psi. The unique and proprietary design of the pump's diaphragm prevents the wear that typically occurs with other types of surface pumps. The pump's closed hydraulic system and the high integrity of the diaphragm ensure long, reliable operation with low maintenance and a much higher degree of environmental protection due to the sealless design without packing to wear and leak. By combining